Stars so bright in the sky. On Arizona nights they fly. Nebulae in colors rare. Galaxies beyond compare. Sky tour in the night so clear. Brings the universe near. Real-time wonders to see. Streaming light for you and me. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. In the dark, the night unfolds. Stories of the cosmos told. Through the lens, a distant dream. Living real like a gleam. Far away, up so high. Across the stars, beyond the skull. Through the lens, a distant dream. Living real like a gleam. Lift your eye up so high. Across the stars, beyond the sky. Sky tour shows us the way. Every night a new display. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new.
Hello everybody, welcome to Sky Tour Livestream. It is I, Mark D'Antonio. At least I think that's who I am. It's nice to see you all here already. And of course, as always, Darrell Mason's with me. Darrell, what's up?
Hello, Mark. I'm good. You? Hello, everybody. Howdy.
Just fine, just fine. Darrell had something he wanted to discuss when we first started, so I'm thinking this is a good time, Darrell.
Okay. If you pay attention to such things, Venus is becoming easier to see after sunset. It's still pretty low in the west-southwest, but if you wait 10, 15 minutes after sunset and you look at the west-southwest, you'll see it big and bright, unmistakable, a little over the horizon. It still goes away fairly early. That's just one you can knock off your bucket list if you have an interest. The second thing, you probably heard about Comet Tsuchinshan Atlas by now. It has been making a really good show before sunrise in the morning sky in the east-southeast, but it is rapidly going away. I think it may go away tomorrow. It has already been by perihelion, closest to the sun, and it's coming up on perigee when it's closest to Earth. And shortly after that, it's going to become visible again and hopefully be much, much brighter in the evening sky. So it's leaving the morning sky, moving back to the evening sky again.
Yay.
And it may be visible on the 9th, if not the 10th through the 14th at least. and probably in the telescope a long time after the 14th. But they're saying it's going to be brightest probably early on, like the 9th or the 10th or so. Uh, on the 10th, I'd say look low in the west southwest, right of Venus a ways, and it'll be getting a little higher each night thereafter. Uh, if you look for a comet in the tail to the right of Venus after sunset, you may need binoculars at first or some visual aid, but hopefully it's going to get very bright. They're saying hopefully magnitude negative numbers. Somebody said -5,
Wow.
which is quite a bit brighter than Venus is.
Yeah.
But that's spread out over the tail and the body of the comet and all. So it's something to look forward to in the first couple of weeks of October. And that's it. I'm sure, hopefully, we'll get to look at it with the telescope here.
Yeah, this would be great if we could actually track it. Usually comets move so fast that we can go back and take a shot every 10 minutes or 15 minutes and then put those together and see them working, see them moving through the sky. Really cool. All right, thank you, Darrell. That was very cool.
Sure.
And what we've got right here, we're looking at the Chinese Dragon Nebula. It's a beautiful nebula. It's near the lagoon. The Lagoon Nebula is to the right. So the lagoon's out here somewhere, just well, about 2 screen widths further to the right and a little bit down to the lower right. So it's down there. But this is a beautiful nebula that we don't get to see that often. And I kind of zoomed in on it a little. Let me zoom out to show you the whole thing once again. And what we're looking at here is we're seeing the nebula here. This is a bunch of dark gas and dark dust, I should say. Okay, it's like a giant snaky line of dark dust. And if we zoom into the middle here, you can see that the characteristic object here, this really interesting snaky line of dark dust is in here. And what would make that shaped like that? I would say the stellar winds in the area, the different movement of dust versus gas, the collision between dust and gas would actually cause something like this to happen as well. So we're looking at the dynamics of a nebula and what it does. Let me enhance this right now. Watch the difference. Ready? And boom. Let's increase the quality right off the bat. Now if we come up to the top here, move it up, you see something very interesting. You'll see this is all dust. You say, well, how do you know that? Well, if you look here, here's a star partially embedded in this dust, and you can see that it has a blue glow around it. Down here we have more stars with a blue glow. Down here we have more stars, and then we have the edge of the cloud, and at the edge of this cloud you see a kind of a blue highlight. This, you're looking at the three-dimensionality of the dust out in the cloud. Okay, you're seeing it curling around, and what's happening is the starlight is from the nearby stars, possibly these stars here, is being scattered by the dust. The dust is really, really good at scattering just the blue light from starlight, because the blue light is higher frequency, and the microns and even submicron sized dust is absolutely incredible, because it can take in all the light and then send out the blue light in every direction. That's called Rayleigh scattering. That's what it's doing. So this is what we're seeing here. We're seeing this Rayleigh scattering in effect. It's the same reason we have blue sky.
Go back down to the dragon.
Huh?
Go back down to the dragon.
Yeah, hold on.
When you're ready.
Yeah, I'm just going to process a little bit. Okay, here we go. So now we come down, and we've got this guy right here.
I always like that bright red patch. It reminds me of like a koi goldfish at a pond.
From the top.
Yeah.
Yeah, that's cool. Yeah, very cool.
I assume that's just a brighter patch of nebulosity.
Yeah, it's probably denser hydrogen. Where it's denser, you'll get more solid glow, and
Yeah.
where it's more diffuse and less dense, you get a less bright glow. And where it's mixed with dust, you'll see it subdued a bit. Like this is all mixed with dust in here, so it's kind of subdued. It's mixed with dust here, and you see it's sort of subdued along the edge. But the most beautiful part of this nebula, in my view, besides this circuitous, beautiful, snaky line, is this part right here. This patch right here is just stunning, because you literally are peeking through this dust cloud at this nebula that's back there, and that's really cool. This nebula here, this dark dust is sitting up here in front, and the nebula's behind it. Very cool. Absolutely incredible. So, as you can see, we've done some exposures already. As I told Darrell before, I like when you come in for the first time, I like having something up on the screen for you to see that we don't have to start and make you wait for. That way we can actually do more objects in the period of time that we want to do them. So that's why I did it this way.
Favor?
Sure. Answer? What do you want?
Bring the koi back up into view, please.
Okay.
Then down to its lower right, see there's right there, that red spot.
Yeah.
Can you zoom in on that?
Yeah, we have enough here. Let's do that. All right, we gotta let it stabilize a bit. Okay.
I assume that's just another patch of brighter nebulosity, but it looks almost like there's something inside it.
Well, look here. There's something dark down here. So this is sort of like, it's a dark patch. This is probably a spot where a star was born within this cloud, and it's it's young, it's hot, and it's ionizing the hydrogen, making it glow. And because of the mutual gravitational contraction, it's possible perhaps that it's become denser because of that.
Yeah.
And that's really cool.
And the dark shadow just under it is the cloud shadow, I assume.
Well, I think that's dark dust, and this was dark dust too, but the hydrogen gas in here is overwhelming the black dust perhaps in here. Just like we see like with the Cocoon Nebula. The Cocoon is inside a dark dust cloud, but its density of hydrogen gas that's ionized overwhelms the dust. You still see dark lanes that are even denser, right? But then it shows through the dark and overwhelms and becomes the dominant color that you see. That may be what's going on here. You know?
Pretty picture at any rate.
Oh yeah, it's beautiful. And this is a really, really pretty shot. I'm gonna see if I can let me see if I can enhance this one more time with just a little bit of the unsharp mask. Yeah, the unsharp mask actually shows you some additional data. Look at this. Now we can see that this line goes like this from way up here. It's not just here, it's all the way up there, and looks like it may go further. That's pretty cool. Let's zoom out a little. Yeah, this is really stunning. This is one of the most beautiful nebulae in the sky because it has everything. It has emission nebula, which is the red. It has reflection nebula, which is the blue. That's really scattering nebulae. And it has the dark dust and the personality with all these circuitous curlicue tendrils. I think that's just so cool. Very nice.
It is.
Yeah, we'll save that right here, just like this. And save it exactly as seen. I wanted to, I don't know if I think some of you actually listened to a Skyter radio tonight with Tara and I, and that was actually a good show. You know, when I write the shows, and the thing is, what I write very often never comes out exactly as I wrote it, which is fine. You know. And let's see. JSCO77 says, folks, say hello to Boston and Maine Live, visiting Sky Tour Live. Boston, where's Boston and Maine Live? Are they in there?
They were
Wow.
a little higher up. But yeah, they're probably out of the top of the frame.
Oh, there they are. Hey, Boston and Maine Live. How are you? Nice to see you. I'm going to guess that's someone I know. And I don't know for sure. Well, first of all, let's run down the list. I want to say hello to Evan, Sky Tour fan. Hi, Evan. He was the first one in. He wins that cookie, Darrell. Sam S., how are you? Daisy and Zoe, how's it going? I hope Lane is doing well. Let's see. We have Carl Becker joining us tonight, JSCO 77, who told us about Boston and Maine. And we have Red Angel with us. Hello, Red Angel. And let's see. Carl Becker said, yeah, saw Venus. You were talking about your Venus thing. Saw Venus. Saw Venus last week in the evening, and it was gone before I knew it. Yeah, true. Tim F. Hey, how you doing, man? Tim, you were late. Several people got in before you. How could you let that be? Donald Kunzer, how you doing? Tell me more, Boston and Maine. Where you? I mean, obviously, you're from Boston or Maine or both. I think you're probably someone I may know. I don't know. Tiffany is with us. Hi, Tiffany. How's Mike doing? Is he asleep already? And we have, after that, we have Marco. Nice to see you, Marco. Good to see you. Rockstar is with us. C&D Boy, Canada. C&D, your name's Doug, isn't it? Am I right? Let me know. And then, let's see. And we have this Darrell guy who's sprinkling things through the chat. Good thing, too. I'm too busy doing the telescope stuff. I can't get to everything. So Darrell is really good at helping and figuring out what conversations need to be had. Oh, look at that. That's really pretty. Okay, color corrected. I'm going to just move this black level up to the top of the peak to get it as much dark as we can get.
Isabella's here.
Isabella's finally here. Yay, Izabela said she was coming. Hello, Izabela. She was probably back. She was probably there the whole time. All right. She said she would come. Okay. Well, let's save this again. This is really good this way. Yeah.
Sam S. has a question. How close could we get to that and still see those features?
That's a marvelous question. If we know the distance to it, I could tell you how big this circuitous line of these tendrils are in light years, and that'll give you an idea. We could actually, if in this photograph, what I'll do is knowing the distance to the Chinese Dragon Nebula, I could tell you how big each of all these many features are in light years. How far, for instance, this little curl is from here. But that's just a minimal distance. Because this here is likely they're about the same distance, but it's possible that this is a little closer, and this is deep inside a deeper nebula segment. So we don't know that actual distance, but we can give you the minimum number of light years that they are distant, and that minimum value is when they're at the same plane. Okay, so we can get the minimum value, but not the actual value. It'll always be a little different.
Does Stellarium give a distance?
Let's go see. It's probably going to say, what, 5,000 light years maybe? I don't know. Let's go and...
I mean, just to look at it, looks similar distance to the lagoon.
It does. And the lagoon's what, 5,000? 7,000.
Something like that.
Yeah, it doesn't give us a distance. It's really hard because, where do you measure distance to? Some of the nebula might be really far away and some might be much closer. And Kyle is here. Hey, Astrolin, what's up? Oh, I've got to tell you about, thanks to Kyle, we're named in a grant from Las Cumbres Observatories, which have telescopes all over the world. And one of the things that I'm going to initiate is we're going to do a study of Barnard star, and I'm going to initiate a study of the Mu Cephei, which is actually the red giant known as the Garnet star. And we're going to do that to actually look for any possibility that there might be planets around those stars. So we're going to go hunting exoplanets around Barnard star. It's been done before, but we're going to do it again because just doing it once is never good enough. So we're going to do it again, and then we're going to do Mu Cephei, okay, which is a red giant, and we want to see if there's planets around that star too. I would suspect if there are, they're going to be, similar to Neptune and Uranus and Pluto's distance from our sun, because the star has gone into red giant phase, so any planets close to the star will already have been incinerated. So we're going to do an exoplanet study of those two stars, and I think that's going to be pretty cool. And now you can see, by the way, here you can see where the lagoon is relative to the Chinese dragon. There it is. Okay, so we'll save it one more time, and then we're gonna take a trip right over and move down to the lagoon, because it's gonna be among the last times you can see it, because it's gonna end up getting really low in our sky pretty quick. But we'll have lots of northern sky things to do. All right. So that's great. Alright, so let's go into our low light mode that I always talk about. Here's low light mode. And it looks like that. And we'll just zoom in a little. Alright, and now we're gonna head over to the nebula here called the Lagoon, and the Lagoon Nebula is powered by a very hot O-type star in its center, which we're going to see right away. Even now, when we go into it in low light mode, you'll see it. Thank you, Darrell, for putting up the address. It's very nice. Okay, and let's just drop it a little bit south right now. We're at the point where if we take this image from the Chinese dragon out here and this, we could actually do a mosaic of the two of them together. Let me zoom in now because I want to show you this hourglass-shaped feature in the center of this nebula. Right.
It's about Chinese dragon's about 5,000 light years from Earth.
Okay. Same as a lagoon, roughly.
Yeah.
Okay.
Well, they look like they're in the same cloud.
Yeah. So this is, see that hourglass shape right there? That hourglass shape is essentially the center of the ionization that's lighting up this entire nebula. And this star right here is the O star that is powering this nebula. O stars are the hottest and bluest stars in the universe. They only live a few million years, and then they always go supernova, and they will blast the smithereens, everything that they're made of, out into the universe, where it will then populate in this cloud again. And when that happens, this entire cloud, the Lagoon Nebula, may go somewhat dark. It won't be as bright as this anymore because this star will then be gone. But the ionization will continue for a period of time as the debris rolls out from that explosion. And we'll actually end up seeing a massive outflow. And at 5,000 light years away, it's going to take a while for that to be noticeable. But we've seen supernova debris pretty quick in the past, like with supernova 1987A. We saw some supernova detail quite quickly. So that was pretty cool. All right, let me That's what I thought. Okay, let me, I'm going to do a focus run one more time. This will be quick. I like having an auto-focusing system. This is great. It spoils me. Remember when we didn't? We had to just, like, guess. Yeah, we've made some progress. Where'd it go? Okay. Okay. Our stars look like little donuts because we have a central obstruction in the end of our telescope. With this style of telescope, you always get that. Hey, thank you, man. C&D Boy says, always amazing, Mark, and Big D, and everyone here. Hey, that's really cool. Thank you.
Big T.
That's you.
Yeah.
Yeah. All right, here we go. We're actually getting some detail here. If you listen to our Sky Tour radio program today, you learned about stellar evolution. And if there's alien life out there, you also learned about what that alien life might look like based on the stars they evolved on and around. And that was kind of cool.
Purple people eaters?
Exactly. Okay, once we get the best focus, once the focus doesn't change, we get this. We get our perfect focus. And the bottom of the parabola, each of these triangles represent a discrete spot that the focuser moved to, and it tested the system, tested the focus there. And you'll notice that the line is not where any of that select point was. That's because it's an interpreted value based on the curve. It's a curve fitting. It's a mathematical curve fitting. And then, there goes a Starlink satellite. And then it will interpret the lowest part of that parabola. And when it finds the lowest part, that's actually the best focus. So we are now stellarly focused. Okay. So we can back out now. And at this point, what I'll do is I'm going to make this a 25-second shot, just like the other. That'll be 25,000 milliseconds. And now we can do this shot, and I will go into deep sky mode. So we're going to pull out of low light mode and go into this, and you'll see the Chinese dragon waiting there. That was the one from before. And if we back out of it, you can see this. Now the lagoon, if I go like to here, okay, the lagoon is like right here. So we should be able to see portions of the Chinese dragon. All right, let's clear that. And now we will get the exposure for the lagoon. Kyle's asking how many degrees apart the Chinese dragon is from the lagoon. It's just a few. I'd have to measure it to get the exact number.
Well, you could probably guess roughly off stellarium.
Yeah. Let's get our first photo in here. Let's see why that one failed. Ah, okay. I see why. We're getting some wind. We're going to let that calm down. Meanwhile, I'll go to stellarium. Alright, so the Chinese dragon is right here. And we're looking at... what was that? Probably like...
Those 10-degree increments?
Well, these here.
the longitude and latitude lines, or the right ascension. Right
Yeah,
ascension.
yeah, it's like
Right ascension.
yeah, those are in those are actually in hours and minutes.
Yeah.
So so I would say I'm really curious why all of a sudden we're getting red lines. It must be picking up. Hold on, let me just get a value. Let me just bring this up. Let's try that. 7.92. Everything's been over 8, so we'll have to wait it out. We'll get something. If we did, it would always end up looking elongated and bad. Well, first of all, this is a 1.5 degree field. So we can certainly see that if we move this over here, it looks like we're looking at less than 1.5 degrees. So from the center here, we're looking at about maybe 1.2 degrees, 1.3. I'm sorry, yeah, not quite 1.5 degrees. So probably like 1.25 degrees, maybe a little more to the center of the Chinese dragon here. So yeah, excellent. So what's going on here? Hey, there we go. We got one. All right, and let's color correct. All right, and let's process. That's gonna lighten things and show you the subtle detail out there. Very nice. Yeah. Again, this is among one of the last times we'll be able to see the lagoon like this, because it's when the sun sets, it's already way past the meridian and heading into the west. But that's okay. Here you can see where that O star is. Okay, and here. Alright, if we can zoom in. We only got 2 frames, but it'll be a little grainy, but I can show you. Alright, so here is the hourglass shape. The O star is right next to it. It's actually kind of embedded in it, because I can actually come over here and use our massive dynamic range. Hey Jessica, Jessica's with us. And bring this down, and now you can see it.
If you see the little dark squiggles here in the lagoon, well, gosh, they look an awful lot like that Chinese dragon does, doesn't it?
Yeah.
If the nebulas are associated in the same cloud, I'm not surprised at all.
Yeah. And when you look at these features, as Darrell's pointing out, they tell you a lot about the evolution of the cloud and what's happened here. And I tell you, like, this is a very interesting one. This is one of my favorite locations in the cloud, in the lagoon. You've got this dark density here, and then you've got this trail, like a comet tail behind it. So the question is, first of all, you don't know if it's coming out of a page into you or going into the page, or if it's flat to you. So as I said, if we measure the length of that, we're only going to get the shortest possible size that it could be. Because if it's going into the page, it could be longer as it goes in, you know. But if it was in the same plane, we can only measure the minimal size, the size at the low end. So that's pretty cool. But still, if you notice now, we have so much dynamic range with this camera that we can literally drop the brightness so much that we can see all the detail going on inside of here. If you were in here, I dare say you probably would not live. You would probably not survive in here. Okay, but look at the colors. It's rich and colorful. Some of this is oxygen, some of this is dust that's scattering starlight.
I like the squiggly dark part that's right there.
Right there.
No, over to the right. Or to the left, sorry.
That's what you meant. So you mean this guy?
That one.
Yeah, it's really pretty.
Sort of a snake-like configuration itself.
Yeah. 51 Cotton, how you doing? He writes, I'm using ancient equipment without a clock drive and all by the seat of my pants. You know what? That's exactly what I used to do. But I'll tell you, it's something that you've got to do. You've got to do. If you expect to learn the sky, you've got to be able to navigate the sky without any assistance. And when we were younger in astronomy, to go to one place to the other, we basically had to star hop by using star patterns. And we figure, okay, that's the star pattern we expect to see just before we get to, say, the Trifid Nebula, or the Eagle, or the Lagoon Nebula. So it's pretty cool.
The old classic Edmund Mag 5 Star Atlas was good for that.
That's right.
Yeah, I wore out 2 copies of that.
Yeah, I have several in the back room here. I have a Scale Nate Pleso back there. I have a Tyrian Atlas. I have an AAVSO catalog with all the stars, all the charts. I've got, well, as you can imagine, you know.
I have a Skalnate Pleso. I keep it boxed up just to take care of it.
Yeah, when I was a kid, I made the container, the cardboard box it came in, into a flip chart style stand-up thing, so I could actually have the charts in front of me. And then I took the time, because I was crazy, I took the time to add glow-in-the-dark paint to every single star in all the charts, so that when you looked at it at night, you didn't have to ruin your vision. You could see the star patterns about where you were going, and it was actually very, very helpful. I thought it was silly at first, even when I did it, but then I realized this really helps. It was crazy. All right, let's come back and let's process now to see where it wants to put the processing. So it's going to darken up a little bit and brighten up a little bit. And now you can see the values and these subtle, beautiful squiggles, these dark nebulae that Darrell was looking at before. Look at these sweeping streaks. They're almost like pillows of hydrogen gas. You see them? Beautiful pillows of hydrogen gas. Now, one thing to notice, and I gotta pull out just a little bit in this. When you look at a nebula like this, we have a hot star in here. This hot star probably engendered the formation of other stars in here like these, okay, because it was pushing stuff out. When that stuff collides, it tends to make the dust coalesce and gravitationally collapse. Again, it's a deep space thing. Hey, Dean Bostador. But one thing I wanted to mention is that if you look around the perimeter, you see like it seems to have edges with these pillow type looks to it, right? It seems like the stuff is sort of folded and bent and folded over as it's sort of going down. It's possible that we're looking at this central area here as a cavity that's been cleared by the hot stars in here, including this O star. And so young clusters in a nebula will clear the center of where they are. When we see the Rosette Nebula in another couple months, we'll see the Rosette Nebula is a perfect example of that. There's a young hot cluster in the middle, and then around it is almost nothing, and then around that is a whole bunch of nebula, because that's the limit to which the young cluster with its stellar winds could push that material outward. That's pretty cool. Okay. This is a gorgeous little thing right here. There's a star in here too. Look at this. Look at the subtle folds in the nebula here. Look at this beautiful nebula. You see all these subtle cloud structures in here. Really quite something. Let me see if I can soften that just enough. There we go. And now you can see that really well. And this is in 3D, remember. It's not in 2D. So this right here, that could be at one level, and then what's behind it here could be like, say, down deeper into the nebula behind, or sticking out. But most likely it's deeper into the nebula behind it, because it's mixing with other stuff here that's probably deeper in the nebula.
That dark patch near center looks like it has a star buried in it too.
This one?
It's not a foreground object.
Yeah, that's what I was just talking about. It has a star in it. And there's one here that seems to have a star. And is it possible that a star formed there? Maybe. But it's also possible, as Darrell says, that that's a star way up here in the foreground and the dark cloud is behind. We'd have to see if there's any studies or go into a database called Sinbad to see. Well, Astrolin is out there. Kyle, go out and look into the lagoon and find this star in the lagoon and tell us how far away it is from this dark cloud. It's probably there in Sinbad. Wrong Way Feldman is with us, known as Fong Wei Reldman. How you doing, man? Nice to see you. Thanks for joining us. Make sure you subscribe too, okay? I'll call you Fong Wei because that's what your name is, and you put in Fong Wei. Subscribe. It's free. All this stuff is free. You get these images free. We have 19 here, and I will save it here. I'm gonna actually change the name up here. This will be Lagoon Nebula. And now when I say save, right, you'll see a green bar appear at the top. Right, that green bar right there is the astronomical fits format that's being saved. But no worries, because I'm also going to save exactly as seen this file, and this is the one you can go and click on, and this is the image you will get exactly. So, and where we were just looking was down here in this region. Look at that. So that's the kind of quality you're going to get for free. If you want better quality, we can do that. We do have a Patreon. If you join our Patreon, you'll be able to get, at certain levels, you get 4 beautiful, highly processed images. And at higher levels, you get all of the processed images from us. And if you just want to support us, we are a non-profit and hanging on by a thread. But you can go to skytourlive.org, which is our portal for the non-profit organization. And there's a donate button right in the middle, and you can donate to us and help support us. It's something that really, really helps us. We don't take any money for what we do. You know, this is truly an act of passion that I do this for. It's just all my passion. As others have mentioned in the chat earlier, I am an astronomer. That's what I went to school for, and I took it down this path of public outreach. Darrell's the same. Okay, he also believes in the public outreach mission as well, and he's been a faithful co-host on Sky Tour live stream here with us for a number of years.
Faithful.
Not so faithful.
I got my degree at the School of Hard Knocks, so yeah. Self-taught in other words.
Oh yeah, but see, that's, and the thing that's important is, it doesn't matter what you got after your name for degrees. What matters is whether you know your stuff. And I've met way too many people that don't, who have all the letters after their names. So I've learned to take those letters after their names with a grain of salt, just so you know. you know. So I'm very familiar with the processes of astronomy. Darrell is very familiar with the night sky of astronomy. And he also has some great stories about the night sky and the mythology and so forth. It's actually been a point that people really like. So I think you get a well-rounded view of astronomy with us. Yeah. Yeah. Okay, Kyle, you got it? You went to Sinbad already? We wanted to find out whether that star in this part of the nebula is in the nebula or in the foreground. Hey, there's Matt, Water Rat 4344. How you doing? Matt used to work for me here. Well, he still could if he wants to. You know, I have a lot of work to do. Rat. Rat.
Saves letters.
Yeah. Okay, NGC 53, let's see, 6530. All right. Okay. I'm trying to decipher what you wrote there, Kyle. I'm glad you went to Sinbad. Yeah, I want to know if it's embedded. I mean, if it's embedded, that could explain why it's somewhat dim. But then again, it could be in the dust and just showing through the dust. What we'd have to do is take a spectrum of that star and see if there is molecular dust in the atmosphere of the star, in the spectrum. If there is, well, then it's embedded in the dust, because we know that the molecular dust wouldn't be in a star that's doing hydrogen fusion because it's too hot. So it would have to be behind it, you know. And then we might see the absorption lines of this molecular dust and then see them in the spectrum. That's how we determine where they are. If we saw no lines whatsoever, then we would be able to say it's in front of that, because it's not being affected by it.
I thought the star looked reddened a bit.
Let's go look again. Yeah, hard to tell. It does look as white as these guys here. But look at the complexity and the network of tendrils and stuff in here. Look at this stuff. Gosh, that's really beautiful. You almost look like you're looking at a complex of like Earth clouds. You'd never guess you're looking at a deadly maelstrom of UV radiation. But that's exactly what it is. Now, inside the dark dust, okay, that UV radiation may not penetrate. So what'll happen is, and I've said this to you many times, you know, life began in the dark. So it's inside these darker clouds of higher density that are protected from the radiation and the stellar winds of these young stars that life could actually take hold. Hey, Goblin.
The little dark cloud with the possible star in it, if you zoom in on it one more time, the dark bit looks like it's just the top end of that longer tendril coming up from beneath.
Yeah.
That right there.
Yeah, now here's what I see. It looks like this continues down. Is that what you're going for?
Yeah, well, actually it winds down into the lower left quite a bit.
Yeah, to me what that says is that there is a line or a layer of ionized hydrogen between us and the cloud back there. Do you see that? Here.
Say that again.
Yeah, here, folks, check this out. Here's a dark cloud. The cloud looks pretty dark, but then it seems like it has a sharp edge to it. it's not necessarily a sharp edge, but a layer of hydrogen here that's ionized, that's also glowing. And it's in front of this cloud perhaps, and if it is, then it's going to mute what's behind it, the dark stuff behind it. So we're looking at a potentially this dark tongue of material sticking out through a layer of hydrogen gas. Do you see that?
I can see that.
It's like a sharp edge. And those, sharp borders in the universe are actually kind of rare, unless there is an actual border to something. And if you look at the undulations in here, there is so much going on in here, and it's so three-dimensional. Thanks, Kyle, for looking into that. Oh, yeah, look at that. And then we back out, and that little feature we've been looking at would be lost to time if we didn't notice it tonight. Alright, so let's go back to our histogram level. We'll color correct one more time.
I would wonder if,
yeah,
as you mentioned, the hourglass blowing out the cavity in the nebula,
yeah,
if those dark wisps are just the last parts of a larger dark cloud that it's blown away.
I would think that there's got to be something to that, because look at the size of the cavity. It starts out here, and I mean, it could be an illusion, but it looks like it comes out at us. It looks like this is the closest part to us, and then what's in here is the farthest part away from us.
Yeah.
I mean, that's kind of what it looks like. Is that really what's going on? Maybe not. Maybe not. It can be more planar than we think or whatever, but the universe is three-dimensional.
Well, as you said earlier, I mean, it's very remindful of the Rosette Nebula, for instance.
Yeah. When we look at things like this, you can actually see how that actually can be true. So I'm not against the thought that this could very well be a cavity created by this O star and this cluster. And when you start getting stars forming in a cluster like this, it keeps happening over and over and over, which is why it's called a stellar nursery, because it forms a fertile place for stars to be born, because the hydrogen gas is always on the move, moved by stellar winds of existing stars that power the nebula, and that starts the gravitational self-contraction. So it may not take much. There's the gravity of everything is trying to move everything out in the universe. If you get a knot of dust in one location that's a little bit more than in another, it's going to start to condense on itself. And if you get hydrogen gas in one region a little more than another, it's going to start condensing. And when it starts to condense, it's going to be more compact, and it's going to be higher gravity, higher mass, and that's going to attract yet more. And then it's inevitable that eventually a star will be born in that region. Here, let's turn on the sharpening one more time and check out these contours. Wow, look at that. Look at this up here, this really subtle region up there. Gosh, this is beautiful. Here's our AllSky camera view tonight, guys. There's the Milky Way, and we are looking right about here. That's the Sagittarius star cloud down there, I believe. And right in here is the Lagoon Nebula. Up here is Cygnus the Swan. There's Deneb, there's Satyr, there's Alberio, and these are the two other stars on each end. And if you need to see that, well, it's shifted a little bit, but you can see that now. Might be able to move that over. Let's see. Yeah, no. Okay. Yeah. So this is where we are. We're seeing Beautiful skies tonight. Last night I wanted to stream, but unfortunately, there's fires, and the fires were, you notice the north, south, east, and west. The fires were actually down to the south, if I don't miss my guess, and we had a layer of smoke over this whole region last night. There was nothing burning nearby. The fire was like 50 miles away, but the smoke came in and hung over everything and looked like clouds. So anyway, none tonight. So we have gorgeous views like this. Look at that. And I think what I'll do is I will full screen this for a minute, get rid of my telescope, get rid of this guy, and let's just jump into this full screen just to check it out. Look at that. Welcome to the Lagoon Nebula, everybody. Really pretty. Really pretty. A lot of this detail in here can be studied for years and has been studied for years. See that? That's a very, very subtle set of details in there, Darrell. Look at that. That's curling around. And this is right here. This is several light years long right there. Yes, Kyle, 7,000 is up. Yeah. That's pretty.
7,000 being North America?
Yeah, that's what I'm guessing he's saying.
Yeah.
NGC 7,000.
Yeah.
Oh, look at this. Okay. I almost don't want to let it go. Let's bring the telescope back here now. And let's dock up our stack. For those that want to know how come we're waiting on the same thing over and over and over, it's because if you notice, it says we've done 27 exposures right there. See right there, 27 exposures. So we take a photo, take a second one, line it up with the first, and put it on top of the first, and then we do that with the third and the fourth, and we keep making a stack. The more images we stack, the less that the noise that's in between all the data is going to impede us, and the darker detail, which is easily lost, will come out. So all the data, it makes the data rise to the top. Because when we take a photo, like say this area right here, all this subtle data in here is lost in the first couple exposures because the pixels are noisy, and so subtle detail gets lost. But if we keep taking exposures of the same thing over and over and over and stacking them together, this stuff becomes very refined, and that's exactly what we got here. See? We zoom in, okay? You can now see a much more refined view of what we're looking at right here. See all that detail in there? We even have a little clump right there that may be a Bach globule, where within there we could have one or more stars forming and one or more possible solar star systems. I won't say solar systems, that's sun, but one or more star systems forming in there possibly.
We've actually stacked 37, and the 27 is now 29 rejected images, frames.
Yeah, that's because of this right here. Over the course of the exposures, we've had some rejections, and that's because we're using the full width half maximum filter, which means that the size of the image, we want to get the image to a certain size, which means we'll have round stars. And so by doing that, we guarantee that our stars are going to be more or less round. And if we don't do that, well, then we end up with elongated stars, and all the detail in here becomes really muddy and no good. So there we go. It's just so beautiful. Let's zoom out all the way here. This will connect with our Chinese dragon, which is up here quite nicely. I'll just have to make sure we do that. All right, we've got 40. We're done. So we're going to save exactly as seen. We don't usually do that many, by the way. This is just an outstanding image, and I thought we'd better do it. Yeah. Hey, Raul. Raul Babadia is with us. How are you, Raul? Nice to see you. All right. We saved it. And now we'll go into our low light mode again. And take us to the next object, which I think is going to be pretty cool. Here's our low light mode. You can see what the low light mode actually delivers. Okay. Now, let's go and move up the Milky Way a little bit here. I want to take, since it's like our last time, I think we probably want to do this. Not last time necessarily, but you know what I mean. We'll go here first. This is another nebula, which is actually a very fascinating nebula. I thought this was a boring nebula for years, until I started doing it with this camera on the telescope now. Because this camera is tuned to the telescope in a most perfect way. And that means that we get to see detail that we just could not see before. And this is Darrell's Duck Decoy Nebula.
Yeah. Also known as the Swan.
Yeah.
Or the Omega Nebula.
Measures 17, the Omega Nebula.
Some people call it the check mark.
Yeah. It kind of looks like a check mark. It's upside down. Okay. All right, so what we'll do is we're searching for our guide star. As you can see, the numbers are rolling, so we've got a guide star already. This is a good region. All right, and we're going to take this exposure and do a 25-second shot here as well. And we'll go into our deep sky mode, so we come out of this. See, can't see much, right? We go into our live stack. And the last thing in our live stack was the lagoon, which you'll see. Yeah, it's beautiful. And we go north of that in the Milky Way, and we find this nebula. So we'll clear this and make way for the next nebula. Now let's see. Hey, we're lucky. Look at that. Okay, that's pretty. Okay, and now what we'll do is I'll move our black level back. See, if I move it way back, you're going to start to see artificial sky brightness come in. And if I move it kind of to here, just before the peak, we still see subtle detail, but we have a pretty dark sky. I mean, our sky is very dark out there. All right, so let's color correct. And now when you color correct, even more detail becomes apparent right away. Let's see, JSCO says, characteristics, Lagoon Nebula is estimated to be between 4,000 and 6,000 light years away. Yep, that's right. Spans 90 by 40 minutes of arc in size, which translates to an actual dimension of 110 by 50 light years. Thank you, JSCO. That's very good of you to say that and help us out. Yeah, that's pretty. This is an example now of another nebula that's a stellar nursery. And this right here, all this actually around it, is dark dust. Our galaxy is actually full of dark dust. A lot of it. And it comes from billions, with a B, of supernovae explosions that have spread dust and material around the universe, and especially in galaxies, especially in spiral arms, where stars are born and die. And when you have a young, hot star systems born in these spiral arms, as Darrell and I have told you for a long time, they only live a few millions of years, 10 million years, 20 million years, because they're so hot and young and have copious energy. So they go through, they go through all of their fuel for the nuclear furnace very quickly, and so they end up going out of what's called the main sequence. They stop fusing hydrogen into helium, and they start making helium into carbon, then carbon into nitrogen and oxygen. And some of the bigger stars start fusing all the way up to iron, which is number 26 in the periodic table. And right there it stops, because when you look at the curve of the return on the investment for fusion, you get to a point where iron is the last thing on the table before you start losing energy, and the star can't put in more energy to lose energy. It just doesn't have the ability to do that. So iron is the last thing that ends up in the core of the star. And I talked about supernovae and stellar evolution earlier on the show on Sky 2 Radio, and one of the things I mentioned is that we're familiar with the element silicon, right? It's right underneath carbon, actually, in the periodic table. And silicon is an interesting element because we have a lot of it here on the Earth. We have a lot of it in the solar system. We see a lot of it out in the universe. In fact, if you look in this dark nebulae, I guarantee you there's silicate grains out here by the unbelievably uncountable numbers. There's so much. But when a massive star starts to fuse these higher elements just before the end of its existence, before it goes supernova, the last thing it does is it fuses silicon. And when it fuses silicon, believe it or not, silicon fusion lasts only 1 day in the star. 1 day. And after that, the star blows up. Okay? So that 1 day of silicon production is all that's needed to fill the universe with silicon, because so many of these supernovae have occurred. It's unbelievable. It's hard to understand, hard to believe, but that's how it works. That's how it works.
When we look up toward the Omega Nebula here, you're just above the lagoon and the tripedal ways. They're all above the tip of the spout of the teapot there, and the center of the galaxy is just to the right of the spout of the teapot, roughly there.
Yep. That's right.
So,
right here. It's right there. Actually, Bod's window is right there.
And when you look up from Bod's window to all those objects shown in Stellarium, that is still the thick of the galaxy right there. That's where things are happening. That's where there's tons of dust and oodles of stars and oodles of nebulae and star clusters.
That's right. Yeah. And we get to see them all. And just because the summer Milky Way is going away doesn't mean we're going to run out of things to see, because the winter Milky Way is just as fabulous and just as interesting. So we're going to have a good time looking at that as well. And then, of course, we have the fall Milky Way, which is going to be there as well as we move into the winter. So it's going to be kind of cool. Let's zoom in on this just to show you some details in here.
When we go from Sagittarius up to Cygnus, that's where you see the Great Rift, big dark band in the Milky Way. You can actually see with the naked eye from a truly dark location, if your eyes are dark adapted. By the time you get up into Cygnus, you're looking over at the next spiral arm of the galaxy, and again there's just oodles of dust and stars and nebulas and stuff there. And from Cygnus you keep going farther north, and you're starting to get into the autumn and winter Milky Way, running on through Cassiopeia and across into Perseus and Taurus and down into Orion and all that when you're in the winter. But when you get up into Cepheus above Cygnus, lots of star formation there, and again, lots of dust. And Cepheus is famous for being a very dusty constellation,
Mm.
and so it goes.
Yeah. Yeah, this is um, the galaxies tend to be dusty places. Nobody sweeps them, nobody keeps them clean. So the maid doesn't come in, so it gets a lot of dust. This you see this dust right here, very interesting because this dust is kind of encroaching on the nebula and it's overlaying it, and it's fairly dense because it's dark. But then we have lighter dust tendrils here. There's a very dark one there. Then we have lighter dust in here. You see that? This is all mixed in. And if you look at this, Darrell, we're actually seeing this it sort of looks three-dimensional to me.
Yeah.
We can't actually say which way things are going in there, but it does look that way. And a fascinating location in this nebula is right here. Okay, you look here, we have this little area right here, and it looks like it's sort of isolated, sticking out a little bit over this blue area. This blue area, again, remember, it's a lot of dust in here. And what do we say about dust? We've got some in here, we got some in there, and it's mixed with the hydrogen. So the dust is actually being illuminated by the stars, and some of it is tinted slight blue because it's doing some scattering, right? So we're seeing a little blue scattering nebula or reflection nebula going on in here. And there's so much detail in here. Gosh, that's just incredible. I'm going to kick up the sharpening by a level here just to see. So I kick that up and we can see a little more detail in here. Wow. Look at that.
When you see that dark nebulosity on the right, that's all closer to us than the bright nebula is. It's almost like we're kind of peeking around a corner there.
And not only that, see this piece of the nebula? This piece of nebula and this piece of nebula are the same nebula. This is the guy that's blocking it. It's up here in the front, like Darrell just said we've been talking about, and the nebula's behind it. So it bisects the nebula and splits it in half. Isn't that crazy? So if this was gone, we would have seen this whole nebula as one nebula. It's a three-dimensional universe, as I said. Yeah, so that's really pretty. All right, we got 18 shots here. We'll go to 20 with this. And then we'll move on. You know what I want to do? I want to do this. I want to see if we can... I'm going to check this out. Oh, there it is. Yeah. We're going to go to Barnard Star. We did a thing with SkyTour back when I had the observatory in the front lawn and it wasn't out in the Arizona desert. We looked at Barnard Star, and then about 10 months later we looked at it again, and we could see that Barnard Star had moved significantly in the sky. Significant for a star. Normally people think the stars are just immutable, they don't change. They certainly do. They're orbiting the galaxy just like us, and the stars closer to us can be seen to be moving against the background of further stars. And Barnard Star is one of them. It's actually the fastest moving star. It has what's called a high proper motion. Proper motion, think of that as a three-dimensional velocity, X, Y, and Z motion in a certain direction. Okay, there's 22. We'll save that. Let me name it, though. This is the Omega Nebula. And we'll save it. I'll wait for the 23rd to come in. Excellent. Now we'll save it. And then save the image. So again, if you go to sky2live.org, you can grab this image and download it. And then you're free to zoom in on it and check it out. If you want to join our Patreon, you'll get this processed and have all the noise removed. If you look really carefully, you can see there's noise in here. We get rid of all that. And you're left with an absolutely stunning image. And we make them higher resolution, so you can actually put them on your wall. I had a doctor's office ask me if I could do one of our nebulae on the whole wall, and the answer is yes, we can. As like wallpaper. I mean, that's how good these images come out. Okay, so we're good there, and at 25 now, we'll save it one last time, and then move on. I'm gonna, before we lose it, I'm gonna take us over to Barnard Star just to check it out. Then we'll come back here and look at the other objects above here that we want to see, and then we'll cruise on up the Milky Way one more time. All right, so let me take us out to about there. Okay, I will, no reticle needed. I'm going to take us to here. We're going to fit the width in. There we go. So here's our entire 1.5 degrees of field here, and our 1 degree of field there. Okay, so now let's go back here, and now we're going to head over to Barnard Star really quick, and it's going to tip the telescope over just a little more. You should see a red star come into view here. All right, let's do an annotation here. There it is, right there. Not exactly right there. And this points out a really interesting problem. Barnard Star moves so quickly. Thank you, Starlink. Barnard Star moves so quickly that even the charts can be off. Notice that inside the plus sign, there's nothing there. Okay? Yet this star is exactly where it's supposed to be. Okay, Hipparchus star 88149, right in the dead center. Where's Barnard Star? Did it go away? No, it didn't. It's probably this right here. Isn't that crazy? So this actually is a great tool to show you how far away Barnard Star has moved already. That's funny. Wow. I'm gonna guess that's it. Let's just get rid of this for now. Save the annotation just for fun so we can have that. And then I'm going to just take a 15-second shot here of this whole area. That's probably Barnard Star right there. And then we'll look at it in here. I'll get rid of this. Yeah, get rid of that. And so Barnard Star will come in. It'll be the red star that we see in the image here. It's a magnitude 9, but there it is right there. That's Barnard Star. And we will color correct. And then do a quick process, and we'll get our view. There it is, right there. Barnard Star is an M-class dwarf. It's fusing hydrogen into helium right there. And as we said, its last known position was down here. But because it's moving so quickly, it's not there anymore. It's moved up to here. Isn't that funny? That's kind of cool. I'm going to save this annotation because this illustrates the entire issue with Barnard's Star. Matt's leaving. That's Water Rat. Good to see you, man. I will talk to you soon enough, okay? Say hi to your 2 kids for me and Lily, your wife. And we will talk again. Yeah, that's very cool. Alright, so I'm going to take... I'll just note this is Barnard star. Okay. Oh, yeah, okay. Yeah. Yeah, we're okay. Yeah. Yeah, shut up. Okay. Alright, so we save the fits file and we'll save... We've got 7 here, so we don't need that many. The whole idea was to see the position. Okay, so it's this star we're talking about right here, Barnard star. Right? This is the one we're talking about. We'd like to do a study and find out if there's anything around that star right there. Might there be another planetary system? Possibly. And so we're going to study that and see if there's evidence that there might be a companion orbiting Barnard's star. Because it moves so fast, its motion in the sky could give away any of the potential planets around it. And it's a small star. And it's actually fairly close to us. The next closest after Alpha Centauri. Yeah, so there we go. Alright, so there's Barnard star. We'll save it with 11 shots here and then quickly jump back to what I wanted to get back to before. Yeah, we are. There we go. So that'll be available for everybody to look at and enjoy. So let's head back into the summer Milky Way. We've gone a little bit toward the west. We're going to come back. Okay. And now go up to our low light mode. Come back here. And let's zoom out a little bit. See, we moved off the Milky Way a little bit. Now we're going to come back in and check out this one guy right here and then move north. So there we are. So we're moving back in now. And you'll see it now. Telescope's moving a little bit. You can see it moving over my head. And we're going here to this strange object. All right. And this guy is one that everybody's familiar with. I wanted to take a picture tonight because all the others are coming out so good that I thought maybe we should do this too, Darrell.
Okay.
Do you have any you'd like to take images of?
I don't take images, you know that.
I mean tonight, Darrell, with the telescope.
Oh, I don't know.
All right, we'll think about it.
Well, the one that comes to mind, as I mentioned before, do the Seahorse again and then swing to the east and catch that cool-looking nebula next to it, whichever one that is. I forget which one it is.
Okay, we can do that.
Cave Nebula or something.
Yeah, we can do that. Is that Cephas?
Cepheus, yes.
Okay. All right, this is going to be a 25-second shot. And we're going to name it. This is the Eagle Nebula. This is the site of the Pillars of Creation. And now I'll live stack that. And get rid of our low light mode. Look at the beautiful Eagle Nebula. And that's just one shot. We have to wait. I can actually color correct it, which will show possibly some more detail. And then I have to bring this level over, which will darken it up a bit because we are at the peak of the colors right there, the peak of the light. And now we see it. There's the pillars of creation right there, guys. We'll zoom in a little while. Fong Wei Weldman says, if you're going to attempt to directly image an exoplanet, which would you choose, knowing that your choice would give you the best chance of doing so? Thanks. Actually, great question. There's a number of potential planet candidates out there. Now, you might think that we should just choose the closest one to us, but that may not work out because the closest one to us might be less visible if it's a planet the size of the Earth or smaller. So I'd have to pick to see an actual planet. I'd have to probably use the Gemini telescope up on Mauna Kea to do that, and image, or the Keck twins up there. Those telescopes would be much more suitable for imaging planets. Jose Navarro says, that's nuts how quickly you picked that up. You must live in really dark skies. Well, here's our sky. Well, this is coming in. I'll show you, Jose. This is our AllSky. There's the Milky Way. These lights over here, this is actually the lights of Phoenix, Arizona, about 75 miles directly to our east. All right. When clouds come in, you see them, illuminated by the city lights out to about here. When they get to about here, the clouds are dark against the sky. They start being dark right about here, actually, right overhead. So this is the light pollution that you cannot see with your eyes. You can see a subtle difference at the horizon with your eyes, but you just don't see. The light pollution with your eyes. You don't see it. It's so dark you can't see your hand in front of your face out there. And this is not where I am. I'm actually in Connecticut, where the skies are much more light polluted. The telescope we're using is one we put in the desert out in Arizona on our friend's land. And we're going to be putting a second telescope in an even darker site very soon. We talked to the people, and we'll be visiting them next week. Actually, Marianne, who's part of our nonprofit organization, will be going down there to visit and talk with them. Okay, so there's that. Look at that. Okay, let's color correct because there's a little blue cast here. Yeah, here we go. That's much better. Now we have 9 shots. Let's zoom in. We don't have any rejected shots, so that's good. Okay. Now you can see the pillars of creation. This is the image that the Hubble Space Telescope took of these. And of course, its field of view was like this, maybe a little bigger. And so was the James Webb Space Telescope. But if you notice, you can see these beautiful pillars. There's really detailed structure in here that shows up tonight. And I think that's pretty cool. And Cosmic Ray talks a little history about the Eagle Nebula, saying it was successfully photographed for the first time in 1895 by an American astronomer named E.E. Barnard. E.E. Barnard is also the man who categorized all the dark nebula, these dark patches in the sky, and made Barnard's catalog, which is really cool.
Barnard was a pioneer in astrophotography.
Yeah. always garnered a lot of respect from me, I'll tell you that. I'll tell you why, because for me, the thing that's most important to me as an astronomer are these dark areas. Because, as I mentioned, life began in the dark, and so the composition of dark dust and how that translated to planets being built was just incredible. It's just an incredible journey.
If anybody's interested, the actual eagle of the Eagle Nebula
Let me back out to show them so you can do that.
is right there near center, a little upper right of center now.
This guy?
Yes. It's basically the same as the Pillars of Creation. I don't know if you squint, if you can see an eagle in there. The dark curve to the upper left is its wing.
This?
Yes. Its central portion is its body and its head.
This?
No.
Or this?
Right there.
These are the talons?
And those are the talons.
Okay.
And the very tip of the central body on the upper right is the eagle's beak, its head.
Right here.
Yes.
Okay.
That is the eagle.
And if we zoom out a whole lot, you actually see what looks like an eye and a beak and a head, outstretched shoulder, wing, outstretched shoulder, wing, with the wings spread. A kind of a skeletal bird of some kind. An anahinga sunning itself. But the Anahinga Nebula probably wouldn't fly. And that's not only what we see. We've got this guy right here too. Oh, look at this. Look at this, Darrell. Look at that incredible detail inside that loop in there.
Yep, that's the fairy.
Yeah, but we've never seen that particular... Wow. Okay. For those wondering what I'm talking about this strange little loop in here. I've never seen that before here. Okay.
That whole figure right there is called the fairy.
And not what I
extending
just,
over.
Sorry, not what I did. Yes, I got
Extending over to the left.
here.
That always kind of reminds me of not that far to the left.
This here.
That's like its base, just to the right of where you are.
Right there?
Right there. Well, that whole thing.
Okay.
Always it kind of reminds me of a old-fashioned hood ornament or a Emmy Award, Oscar
Yeah.
award.
There you go. Now, the interesting thing about this nebula, which I've talked about many times, is here's a hot young star cluster in here. These stars are very young, and they have cleared away a lot of debris in here, and they send out tons of ultraviolet radiation and powerful stellar winds, all right? And as they do, they ionize the hydrogen with the ultraviolet radiation, and the stellar winds will push dust and gas away from them and clear the way. But areas that are denser, like the front of this, the front of this, the front of this, okay, these stay, and so they protect what's behind them. So these stellar winds blow stuff past this area. This is very dense, so what's behind them are protected, and so that's why we get a stalk eventually. And when this first happened, when this first formed, you probably didn't have any of this here. But then over the course of a few million years, this material that was all up in here before now got blown down to the sides. And the denser parts just stuck around and protected what's behind it. That's the theory and understanding of stellar stalks and nebular stalks that we see. There are pillars, there are stalks. Okay, they're elephants' trunks, they're called sometimes. So But this feature is common. We see that in a lot of different places. Another feature that's really interesting is a feature illustrated by this guy right here. Let's zoom in real close. It'd be a little noisy still because we've only got 23 shots here. But as we come in here, I want you to notice something right next to the pillars. We have a dark dust blob here, and then we have a trail behind it. So dust is being eroded away by this hot young cluster, which is only a few light years away from this. And it's eroding away dust and spreading it behind it a little bit. And we see that. But it's not getting rid of this entire blob because the central part of this blob is really quite dense. So it's not coming away and being able to get squirreled away by this stellar wind. Right? So again, we see trails left by these stars. Right, the hot young stars, they will leave trails of debris in their wake.
There's another little dark blob just to the left of your pointer there, yeah. And even tinier one to its lower left.
Oh,
and
okay. Oh yeah, right there.
I mean, they look close to the cluster, but they're almost surely in the foreground.
Yeah. That's something. Yeah, this is a beautiful cluster because it has so much going on in it. I'm sorry, nebula, because there's so much going on in here. But we can actually soften some of the noise by dropping this down to about here. And now if we soften the noise, you'll see that it looks a lot more beautiful and subtle. Really pretty. So if I do this, pop this out a little bit, it'll get a little brighter, but look at that. You can see the really fine spider stalks sticking off of this main pillar. See that? We haven't been able to see these before. But it's an exceptional night out there, and we're able to see them. Look at it, see right there? We're seeing more stuff sticking off the top of the pillar. That's fantastic. I love this. This is an amazing view. Kyle says he prefers our version of the Pillars of Creation over JWST and Hubble. Hey, Cosmic Flow 888, what's going on? How are you? It is beautiful. Let me see if I can pull out some of the red a little better. I think I can. I think I can show that nebula much brighter. Here's the overall nebula. Let's take it out. Okay, here you go. You see it's a subtle, this is diffuse nebula up here. So the hydrogen gas is sparse up here, but enough to glow over many light years in size. Here it's a lot denser, and so we're seeing this dense hydrogen gas glowing in here. We're seeing it out here as well. Beautiful, beautiful, beautiful. Beautiful, beautiful. We will save that and save this exactly as we see it. Now keep in mind, you go here to skytourlive.org and you scroll down, and as you scroll down, you can see an area that says "Take me to cool pictures" with instructions how to get them. So you can actually go to the directories directly yourself, and Darrell has been very good about putting up the address to them, and Izabela. But we are working to get our app up and published so that we'll be able to you'll be able to download our app for Android and iPhone and go through all of it and check all the pictures out, download them on your phone, and the app works on the PC and the Mac too, so you can actually download on the PC from the database that is years long of data. So you can go to every time we looked at the Eagle Nebula and compare them and see if anything's changed. When you see if things have changed, you have the chance of actually making an actual astronomical discovery, you know, and so there are things that have changed. Sometimes there's an asteroid that comes through the field, and you can identify the asteroid. If it's not identifiable, then it could be an asteroid that you get a part in naming. So that's pretty cool. James Hyatt's with us. How you doing? That's good. Cosmic Flow, we are doing fine, thank you. I'm doing fine. Thanks for asking. Yeah, I'm looking forward to getting it published, James, and we will get that app out there. I think it'll be very well received. I've previewed it here, show folks what it looks like, and we can do it again. All right, let's see here. We'll do one more, 35. We'll save it and move on. We only rejected 2 frames so far. Let's see if this one came through. Yes, it did. Okay, we'll save and move on. So we'll save exactly as seen. Let's also annotate this image. We certainly know what it is. We know what's there, but by annotating it, we can actually do that and then save with annotation, and that image will be available to you as well. There you go. Excellent. Darrell, thank you for putting up the addresses for images and so forth. I'm going to make a mod run, which means I'm going to go through and look at everybody who's a moderator, and for people that have participated in moderating, I'm going to leave you guys. I'm going to add more for the people that would like to, and if you haven't, well, you may be taken off the list. Okay, so there is our low light mode right here. Boof. All right, so now let's go and head up all the way up the Milky Way here. Now let's I'm gonna take us to the Seahorse. That's up in Cepheus, and so I want to go up to Cepheus. It's up there. I'll have to spin around. Okay, spin around too much. Yeah, okay. Come on. Well, it's all right. I will get there. I'm trying to make it spin around. Here we are. Okay. Hey, whoa. That's not what I wanted. Okay. Alright, so Cepheus is really high in the sky right now. And let's see if I do this. Okay, this is our zenith up here. Alright. And so Cepheus is just off the zenith. Alright. And looks to be just let me go back here because we're going to come back to it. Yeah. So it's on that side of the pole, and we'll be able to see it. Okay. I'd like to go to Deneb first, actually. Actually, I don't have to anymore. I just realized I don't have to do that kind of thing anymore. I was trying to line things up. What's the Seahorse Nebula? What's its identifier?
I don't know offhand. Give me just a second. I'll find out.
Let's see if I can find it this way. No. it doesn't know the English. But what I can do is...
Barnard 150.
Oh, it is?
Yes.
Okay. Well, let's...
And yes, that's the same Barnard.
Yeah. Okay. Why is it saying Mu Cephei is... Oh, Mu Centaurus. Haha. Wrong one. I got the wrong one. I wanted Mu Cepheus. Mu Cephus. There it is. That's better. Alright. Let's go here, because it's going to take us up there anyway. Into Cephus. Or Cepheus, depending how it's pronounced. Many people pronounce it differently. Alright, so here we go. The telescope's going to lean way the heck back. And we're going to look for a bright red star that comes into the view. Well, can't miss it. Right there. Alright. And what I'll do is show you a new capability we've got here. We're gonna do this. You'll like this. See that right there? Okay, that's the Garnet star. Alright, so I select it in my list here and I say center it in the view. And so now it's going to center Mu Cephei. There it is. Now we're centered. So now Mu Cephei is centered, and so all we have to do now is, if you want to synchronize, we can just say sync right here, or come here and say, if we zoom in, now you see where our crosshair is, and we're upside down right now. That's why everything's upside down. But now we're going to synchronize and make sure our telescope and our coordinate system and our computer are all lined up, and now they are. All right, and so this is Mu Cephei, and I'm going to do this. And there we go. Excellent. Okay, let's just take a 20-second shot of this.
That was a proper name. I didn't know that.
Oh, you thought it was Erakis, you mean?
Yeah.
Oh, okay. Erakis, the spice must flow. That's A with an A. This is Erakis.
A and 2 R's.
Yeah. Baron Harkonnen. House Harkonnen, House Atreides. And you gotta be on some kind of wacky stuff to come up with that sci-fi, I think. Well, there you go. Look at the color of the ring. This is a ring created by the system. It's a halo. But if you notice, look how red this is. It's a crimson red. It's really just a stunning star. It's also a red supergiant star. And so we're going to study this star and look for planets around this star too, as part of the award. And see if we can find if planets are there that may have survived the red giant phase of their star. For instance, in our solar system, when our sun goes to red giant phase, if you do that, well, what you'll find is that the Mercury, Venus, and possibly the Earth will get swallowed up by the red giant size of the sun. Then it will eventually shrink and go to a white dwarf.
It's also a carbon star, is it not?
A Musifi is a carbon star, which is why the crimson red, yeah. And these carbon stars dredge up the carbon, which is, again, the fourth most abundant element in the whole universe. They dredge up carbon from inside because these stars are stars on their asymptotic giant branch, where they have gone to red giant phase for the second time. I've talked about this before. And when they do that, they will dredge up. There's a first dredge up, a second dredge up phase, where they will actually have these deep convection cells, which will bring carbon up from the interior. And when it does so, that carbon in these red giants is goes so far away from the center where the fusion's going on, that you can make carbon bonds with other carbon elements, carbon atoms, and you get carbon molecules, and it makes kind of a soot, and thus it reddens the star's light tremendously, and that's what we see with these stars right here. Yeah, let me pull this back a little bit. Yeah, that's something. You also see red nebula. That's really there because we're near another object. Actually, it's within just a few degrees of where we are. But we're gonna look for the Seahorse tonight, and then we'll come back to this one later. I'm also noticing, and I'm sure you just saw it too, Darrell. This thing, what is that? I'm wondering if that's a object or a lens flare. Let's zoom in and find out. Let's see if it's something known. I don't think it is. Yeah, it's not. Wonder what that is.
Stellarium show it?
Yeah, good point. Let's go look. I may have to bring up other catalogs. And we're right side up here, so if it's to the upper right, it means it's probably to the lower left or lower right.
Go back to Stellarium. There's a little gray smudge over to the lower left of Garnet star.
This?
Farther left, right there. Next block over from where you are.
Here?
No, go down 2 blocks.
That's 2 blocks.
Over 1 block to the left.
Oh, that.
That right there.
Well, let's look at the stars and see. Yeah,
it's very blue, whatever it is.
Yeah, usually that means it's a lens flare. From the bright Garnet star, but the Garnet star shouldn't do lens flares of that color. So this is possibly something else. That's interesting.
Colored like a planetary nebula, sort of.
It does, doesn't it? Yeah, I don't see what that might be. Let's try this. Let's come in here and say, is it F5? No. F4. Let's go into our DSO. Let's pull in the Lens Bright Nebulae catalog. Let's move this over a little because it's not big enough. Sharpless catalog. Barnard catalog. That's Lens Dark Nebulae. Any other catalogs here? No, the rest. Oh, let's try this one too. Okay. Now let's come out and see if it's listed in here. Aha! Look at that. PK100 possible planetary nebula. Look at that, and it's blue. So I think that's interesting. We actually saw something that we've not seen before. Now, again, because we're upside down, you gotta flip your head upside down. It'd be to the lower left, okay? Because our telescope's tipped backwards and looking like you're looking up, straight up, with your head tilted back a bit. So it's gonna be upside down to you. Because we come in here, you'll notice we look at the words. Like here, okay, that's upside down.
I think if you draw a line from the Garnet star to that object, like in Stellarium, you see the stars in between the two.
The double stars, the two stars.
Yes, there's that pair of stars and a couple of other ones.
Yeah, let's go do that. Draw a line between here and there.
There's the pair of stars.
Okay, so we have a correlation. Interesting. This is the pair of stars here.
Yeah.
Okay, so this is good. So we've got a we have a possible planetary nebula right there. That's nice. Right, and because we've been doing this for a while, we actually have a way to note this, and we're already, because we set the center, it names it for us already, so we can actually just say save.
I get a Scooby snack.
Yeah, good for you. Well done. Okay, now that we did that, let's go look at the other object we wanted to see before. This is nice. Okay, away, let me do this. Save image with annotation. Okay, now we can get rid of this. Climb out of our stack. Go back to our low light. Alright. Okay. Maximize. Great. And now let's fit the width again. Just to get back to that. And our mu Cephei will be centered. Excellent. I need the Barnard name again. Sorry, Darrell, for the Seahorse.
150. 150.
All right, let's go see where you are. That's it. Let's check out the Seahorse.
Can we do one thing first?
Yeah.
Back out more in Stellarium.
Okay, we gotta let this get there first. And then we will. Alright.
Okay, I don't see it.
What are you looking for?
Well, the object we saw to the left
In this?
of Barnard 150.
How was this?
Okay.
Yeah.
Well, that's a star.
Yeah, but there's actually a... I think there's a nebula in here. We'll find out. Let's go.
Alright.
Let's go check it out. All right, let's look for that. Again, we're upside down, so over on the right side, we should see two stars. Okay, and I don't see them. So let me annotate this and see what we've got. Okay, it doesn't have any objects to see in here. Alright. Maybe we just pull to the west a little bit. Oh wait, those are the two stars. That's what I think's going on. Okay, let me just go look at that again. We should look here. Yeah, so we have the orange star, and then we have the little star underneath. And that's on the left, but it'll be on the right. There it is, orange star, little star underneath. There we are. Okay, so we're in the right spot. So I just have to maneuver to have this guy over toward the edge a little bit. All right. I think that means I go this way. Because this, I believe, is the Seahorse right here. Yeah, it's a dark nebula, guys. It's really very interesting looking. Alright, so we're gonna center that up. Alright, should we try it?
Sure.
Okay. Okay, this is gonna be a little longer exposure. We're gonna do this one for 30 seconds. Alright, and we're already guiding, as you can see. Hey, Pra, what's up? Nice to see you. Okay, we'll go into our low light. I'm sorry, our deep sky mode. That's Musifi. We'll clear that. This camera also delivers wonderful color as well. Very pleased with how it works. Okay. Okay, there we go. Now, you say, well, I only see stars. Well, this is nebula here. It goes here and here. Down here. And it will become apparent as soon as we get a few more exposures.
So, I mean, I know the answer to this, but if we look at something we've imaged before,
yeah,
the telescope is going to be sitting in the same orientation every time, right?
Yes.
Yeah, okay. So, when we're done here to catch that next object I mentioned, I believe it'll be off screen to the left.
Okay. Well, let's go. Off screen to the left here means off screen to the right here. Because we're upside down.
Well, let's worry about that when the time comes.
Okay, okay. You can see our bright orange star with the other star. You can already see how this dark dust is taking on a weird tonality. It's got a different tonality. It's also brown, all right? And that indicates that there's a lot of silicon in here with carbon. And so that's an example of where we see the supernova debris manifesting itself in the universe like this. Let's do this. Let's do that. Now we've only got 4 shots taken so far. But this is called a push when you pull these two back together. Now you can actually see what's really in here, hiding in the background. So we're actually gonna draw that out over time here by just adding more images on top of each other here. Michael Hedrick. I thought you just abandoned us. And here he is. He's back. Good to see you, Michael. Jose Navarro asked a question. He says, would that, meaning the Seahorse, be the stellar nebula that created the surrounding stars? Not necessarily, but that's a great observation, actually, Jose, because we know that within dark nebulae, if there is a nebula, if there's a lot of hydrogen, they will make stars and could possibly make stellar nurseries. But we might see some remnants of that here, but a lot of time has passed in the universe. So the stellar nebulae, or the nebulae that these stars were all born in, may very well have already become invisible over time. Possibly because the stars, when they were made, had enough energy to possibly ionize the hydrogen gas for a short period of time, and then as the stars matured, they moved through the universe, the gas cloud moved away and was no longer ionized. But we see this leftover piece, this might have been in that stellar nursery that these were in, but I'm going to guess that the stars that we see here in this view, like this, are stars that are more distant. And these, of course, this object here is in the foreground. So it might be a dust cloud, and maybe some of these stars, like these, okay, or maybe these red stars, could be at the same level or in the foreground to that dark nebula. I can't say for sure, though. I'll change the name of this to Seahorse. I do remember that it was a nebula or something that we caught with the Seahorse.
Yeah, I'm looking now. I believe it is just out of frame to the left.
Okay. It's color correct. Okay. Notice that color correction made this all stand out a lot more. Yeah, let's pull this over. And I'm going to pump this up by hitting this button over here. This will kind of show us what's there. And now you can see the nebula here, hiding in the dark. It goes all the way out here, down here. That's really impressive stuff. Okay. 13 exposures at 30 seconds apiece. 6 minutes, 30 seconds in. That's how long of an exposure we've been adding up here. Cosmic Flow 88. Yeah, I think for like 56 days or something, we're going to have a very small temporary moon here. And I think it's something people ask, can we go look at it? Can we see it? Again, it's very far away and it's very small. So the answer is we're probably not going to be able to see it. I think it's 2024 PT5, isn't it? Designation.
That sounds familiar.
Yeah. Keith Evans, how you doing? You can see some of the details now in this cloud are coming out. Let's try and push this here. And let's pull this over into the peak just to give us as dark a background sky as we can get. Yeah, you can see the details in here. That's actually pretty cool. Now let's see if we pump it up, what happens. Alright, I'll pump up a little bit. Oh, look at that. That's pretty cool. Okay, we're gonna come out of this. Leave this. And we got Seahorse Nebula, so we're gonna say save right here. 17 shots. We'll go to 20 with this. Just out a shot to the east.
To the left as the image shows.
So that's over here.
Not if you're upside down.
So you mean the right?
Well, to the left in the image.
Okay.
Cosmic flow, no, it would not be visible in the daytime, much less at night. Or much less in the daytime, and it's not visible at night. It's far too small. The object's only about 36 feet across, and it's over 500,000 miles away. It's like 22nd magnitude. We can't see it.
That's very faint. Michael Hedrick, wondering if you could slingshot a star and hit another star, or would they repel each other? What would happen? Well, what would happen is that stars have gravity, so if you slingshotted one star into another, they might enter this very highly elliptical dance for a period of time until they may actually collide. Now, if stars did somehow collide, that could in fact disrupt both stars. In other words, they would explode, possibly, because it disrupts everything that is the equilibrium, creator within each star, and you don't want to disrupt the equilibrium of a star, because that's looking good, Darrell. Equilibrium in a star, you don't want to disrupt. So you probably could make a stellar collision cause effectively a supernova, just from collisions. Now, not to worry, there's no stars that are even remotely going to collide with our planet. Even in a very, very dense galaxy, stars don't usually collide. Hey, Cindy. Cindy Murphy's with us.
I see that.
I was telling that to everybody because I saw you had said hello. Lewis, hey, good to see you, man. Don't worry, it's all right, Lewis. Lewis says he's sorry he's late. Well, you know what, Lewis? You're not late for class, okay? You're just late for the universe. But don't worry, it'll be here tomorrow. And around tomorrow it'll be here at precisely the same way it was here tonight. Bentley 625, Buckeye, Arizona. Hey, welcome, man. We're gonna have let's see, we're out in the desert, southwest of Wickenburg, out in the Sonora Desert, with this telescope, and we're gonna be doing another telescope in Benson, Arizona. We already have it. It's pretty cool. And Mr. Django is saying to us how he's partying in Spain. Well, wow. But he's here watching. How you doing, man? Are you watching on a phone? Oh, he's back in Belgium now. Okay. Yes, if you guys want to see a cool site, go to Mr. Django's Backyard. That's look him up online. He does a lot of astronomy himself, takes photographs. And I dare say he's pretty darn good. So, let's see, we've got 26 images captured here, no rejections. Look at the subtle difference here, Darrell. Look at all that stuff. Very subtle. Let's push the process again. This is really pushing. Oh yeah, look. Now you can see the lights and darks in this nebula. That's really nice. Very nice. Bentley says astronomy in the White Tank. White Tank's a mountain range. White Tank Regional Park sometime in October. It's interesting. I'll be out there for the first week or 2 weeks of November because I'll be teaching a class out in the desert. Actually, I'll be doing astronomy out there. I'll be at Weaver's Needle the second weekend of November. We do classroom and then we go out into the field. So I think Friday night or Saturday night I'll be doing an astronomy skywatch for everybody out there. And so they're bringing me out from Connecticut to do this. They do it every year. But what's the White Tank event going on out there, Bentley? 625. Okay. We've got 30 shots here. I'm gonna save this here and save exactly as seen. Let's see if it knows anything here. Does not know anything. That's okay. Alright. Alright, well, there we go. So you're saying, Darrell, it's to the left in this image?
Yeah.
Okay.
Scoot the Seahorse out of frame to the right.
Alright, let me do that. So we'll get out of this. Go back into our low light mode. And in this low light mode, we will scoot the Seahorse out of the frame by heading east. You watch our stars. I think I see something here.
Stop right there.
All right.
Can you try an exposure there?
Yeah, sure. All right, so we'll do 20 seconds, 25 seconds here.
This may or may.
You just muted.
Yes, I know.
I think
No, I just
250.
unmuted.
All right, let me. Here we go. Okay, let's. That was the exposure that we got to that point. Well, we'll find out. Let's live stack this. There we go.
I don't know if this is going to be what I'm looking for or not, but we'll see.
Okay. Well, we see more dark nebula coming in here.
Okay, maybe go a little farther then.
to the left again?
Yeah,
Alright. Let's try it.
I haven't been able to find the image. I saw this at before. One image I did find a little while ago shows a big red swath of nebulosity coming down to the left of the Seahorse, though.
Was it a remnant of the bubble?
I don't think it was the bubble.
Let's keep looking. See, folks, we're just exploring. It's kind of fun. I'm gonna move over. Should we try this?
Sure.
Okay. Get out of low light mode. Head ourselves into deep sky mode. See what we get. Alright, that's the previous shot we just took. We're going to find dark nebulae all throughout the galaxy, but there's certain features that are recognized and named, which are really cool. Okay, what do we got? Maybe here?
It was pretty obvious. I don't know. I'd say carry on. Never mind.
Okay.
I'll have to do some more digging.
Yeah, we do some digging. If you find it, we'll check it out.
Okay. Would you excuse me for a moment then, please?
Yeah, sure.
Be right back.
Okay. Okay, let's go here, and let's expand this into a little larger. All right, and let's back out of here. Oh well, look at that. That's probably what he was talking about right there. That's what he was talking about. Okay. Now that I see it, we're going to go there. And you can see us go even more to the east. Here we go. That's funny. When he comes back, we'll tell him. Guess what we found? Alright, so that's where we are. Okay. And that orange star is this orange star, so it's not quite lined up. But I will do a analysis of the frame. And okay. Alright, Hipparchus 104,719. And that corresponds probably to one of these stars. Is it this one? 104,883. And this one here. Maybe it's this star. Oh, it's not given a Hipparchus name. Okay. And it's probably going to be all right, so it's going to be Hipparchus 106 104 642. All right, let's go here and come back. Is it that guy? Gotta zoom way in. It's a planetary nebula. Okay. Alright. Well, that's the orange star right there. Nope. Okay, well, we're just gonna do this. We'll take a photograph. I know what you were looking for.
Yeah.
Yeah. It's a
Was it the flying bat, not the
Yes.
seahorse?
Yes.
Okay. Well, whoop it on us.
Yeah, we'll see if we can see it. So it's just a little bit south. Let's do this one shot. All right. Maybe this is it. Let me see. Make sure I did it right. Okay, there's the red star. So maybe I went the wrong way. I think I went the wrong way. Sorry. Okay, so let me go back. Yeah, to the north. Okay. There's our two stars again. If we do this, that tells us what we want. Okay. And 10642. 104642. Okay, we'll center that in the view. So it'll center it. This is our crosshairs. So we get 104642. Pretty well centered. That's good. All right, and now I'm going to go to that star, and let's make sure that I can. That's not what I want. Okay.
You're going for the flying bat?
Yes.
Uh,
I'm looking at. I was just trying to get the coordinate systems. Okay.
yeah, okay.
Because one of these is a planetary nebula in here.
There's
We got the flying bat in here, so I'll just do it.
Sharpless 2-129,
Right.
and the Squid Nebula is in there too. I know we've tried the squid before, and I don't think we ever caught it much.
The blue we couldn't catch.
Yeah.
All right. Well, here's what I'll do. I'm going to. This star right here is V419. Oh, 104719. Okay. Let's see. That's going to be the red star in here. That's going to be this guy. And again, we're upside down. Yeah, to the upper left of it, which is going to be the lower right of it, we have this. Okay, so we're good. I know where we are. All right. So that said, we are dead set kind of right near the flying bat. So we're going to actually try a 25-second shot, but I'm going to do something a little different. I'm going to increase our sensitivity quite substantially. I'm going to take us to 300 sensitivity here. Okay.
I wonder if this will be the first time for the squid with the new camera.
Oh,
The better blue sensitivity might help pick it up.
that's true. Let's find out. All right. Well, here we go. 25 seconds at 300. Okay, well, first things first, let's get the curve straightened out. Get our color. And get our adjusted curves. Well, there's a nebula there. There's a nebula there. Okay, let's do this. let's go check out what's in our lower right here. This is Bright Nebula. That's this guy. Okay, that's the H2 region we're looking at right here. Again, it's in the upper left, so upper left here. All right. Then we have Bright Nebula at the lower right. Okay, and that's going to be this guy right here. You can zoom up and see more of it, maybe. Yeah, there it is. Okay, and let's color correct that again, because we need to. There we go.
Why is your histogram so differently shaped than usual?
This one?
Yeah.
Is it? I mean, it's just, it's like, it seems like it's the same.
I don't remember all the lines trailing off on the left like that.
Oh, well, normally I would actually just bring it to like here, so we don't usually see that too much, but
Oh, okay.
yeah. Yeah, we got some really cool stuff coming through here. Got some diffuse nebula here, some nebula there. I'm not seeing what I expect to see though.
Where is the squid?
Oh,
I mean, the
squid.
squid. The squid is right in the middle of a bright patch of red nebulosity.
Okay.
Makes me think it's off screen to the left.
Yeah, but that's okay. Let's take a look at it again. Okay, that's Bright Nebula 449. No, I'm sorry. Bright Nebula 453. Yeah, that's 453. Well, let's try. Should we just try to go over to the left?
Yes.
All right, so we'll do it. We're gonna head over to the left because this is something we want to try. All right, now we'll go and bring up our low light, and we're gonna move to the east again.
I never did see a flying bat.
I know. Okay.
Try that.
Alrighty. We shall try that. Well, okay, that. It was queued up. Okay, at 300, we're gonna do 25 seconds again. And go into our deep sky mode. That's the previous image. We're gonna be in the middle of this now. So that should be right about here. Let's see what we got. We're hunting around, guys. We're going off together on journeys and forays through the universe. Well, there we go. That's the object right there. Those two stars are quite beautiful together.
Oh.
Let's add some correction to the curves. Do this. Bring that up almost to the peak.
Um,
Yeah, I don't see it.
okay. Well, let's carry on. I'm afraid we're boring people. The Flying Bat Nebula, or is it Sharpless 129,
Mm-hmm.
is an H alpha emission nebula commonly called the Flying Bat, located in Cepheus, very close to the famous IC 1396, the nebula that contains the elephant's trunk.
Yeah, which is, I think, down here and below. Okay, well, let's see what we're looking at here. Oh, wrong way. Oh yeah, no. Okay, yeah, it's the right way. So this is the elephant's trunk right here. And it was to the lower left of this. Let's we've seen the elephant's trunk, but we can check it out again at some other point. Let's look at the cave. The cave is going to be over there. And I'm thinking we should check out the cave. Let's go back to this. Get out of this. Go into our 1 second low light mode. Oh, look at that abstract that was created. Alright, let's do this. Annotate, see if it knows where we are. Well, I don't know where we are, but does it have anything? Okay, Cave Nebula. So the Cave Nebula's right here, so we're good. And that looks like a pretty good placement for it, Darrell. Okay, and we will... Let's do a 30-second shot of this. This nebula has a number of other really cool features in it, including some objects that if I recall, these are the Herbig-Haro objects in here, which are young protostars that have just sort of winked on. That's the previous image. Ooh. Stargazing event at the white tanks. Yeah, there's the cave. There's the Herbig-Haro objects, the protostars. Here's a reflection nebula, which will really show beautifully. This is a dark dust cloud with some ionized hydrogen on the back side of it, which kind of silhouettes the cloud. It really is pretty. So we'll let this come in a little bit. Let's color correct it first. Alright, and now we can drop this peak right here at the peak. I stay just to the left of the peak in most cases. Okay. This beautiful reflection nebula, blue material with dark dust interspersed. These two stars are scattering or their light is getting scattered by the dust. So that's just crazy. But common in the universe. That's the blue sky for the universe. Okay. So I'm gonna mark this as the cave. Okay, we did 3 with 1 rejection. so far. Okay, the second one was rejected. Yeah, we're at a good level. If you want those green lines to be as close to your threshold as possible, and that's a good thing. If they're down here, then you could lower your line. But if you have a good estimate of the sky jiggling around and so forth, then this is what you would find. You want these lines to be really close to the tops of your columns without many of these. Okay, like that just came in. That's good. Oh yeah, this will be real beautiful. It's going to be probably one of the better caves we've done, because look where the telescope is. It's actually pointing pretty much almost straight up. It's a little bit back. So we're going to get the best rendering of the cave that you could get, because we're looking through a minimal amount of air. Yeah, there we go. That's nice, Bentley. It's a good location. Bentley says I take my glass out to the same area during the winter. That's cool. Mr. Django says, for me, I was fast asleep, but something told me to wake up. It's STLS time. That's right. No, Bentley, we're not on Vulture Mine. We're on protected land out in that region, though. It's a really nice location. The sky is a Bortle 3 sky. Solid Bortle 3. Where we are. Oh, Izabela's probably lurking. She may have fallen asleep, though.
Yeah.
It's early in the morning for her.
Well, it's 8 o'clock in the morning for her now.
Yeah.
It was like 5 a.m. her time when she showed up.
Yeah.
Which is really early.
She might have actually fallen back asleep.
Maybe. Hopefully. She had trouble sleeping last night, I think.
Lubo in China's with us. Hey, Lubo. Says he's driving now. Any chance for Saturn? Not tonight, Lubo. We're actually... this is our last object for tonight. But we'll be able to check out Saturn for you in the next Sky Tour. Bentley says, getting much atmospheric distortion from the heat. The answer is surprisingly no. It's actually pretty steady out there. Yes, the desert gets very warm, and yes, what happens is as the desert releases that heat, as the evening approaches, we do get some winds generated by that heat release. But after that's done, the desert is remarkably steady. Very, very nice. Wow. Yes, Lubo. He says, "Is your big one ready for planets?" Yes. The other telescope that we got is going to be perfect for planets. We'll be able to see probably features on the surface of Mars. Easily see the cloud bands of Jupiter. And very easily be able to see all the details that you would expect to see in Saturn's rings and so forth.
Saturn's rings are nearly edge on.
I know. That's the other thing I was just thinking. It's like, well, maybe not exactly all the detail we should be able to see. It's, when they go edge on, you're gonna almost not see them. It'll look like Saturn's just a yellow planet. You won't see Cassini's division except at the extreme edges, as long as you got a little bit of a look angle looking down on the rings. Look at that. Cave is looking pretty. Here, let's get rid of the telescope for a minute. Okay. And let's get rid of that, and let's I love gesturing and seeing things go away, and we'll do this. There we go. That's our cave. These are the two objects I was looking at with you before, telling you about. These two objects down here are Herbig-Haro objects. They're protostars that have basically just winked on. Okay? Oh, sorry, that's a little big, but you get the idea. Alright, so it's right here. These guys. So they've just winked on and are ionizing this nebula around them. Up here, oh sorry, I meant to say it this way. Up here in the cave, as we move this around, okay, you'll see that we have this dark fringe here. So we're seeing dark nebulae interspersed with this ionized hydrogen. Very pretty, and also very telling about how the universe mixes materials.
Mr. Django has a nice comment for you.
Where is he?
Down at the bottom.
Oh, Mark, my AllSky cam works great after following your advice. Thanks. Oh, sure thing, Mr. Django. Yeah. Speaking of the AllSky, let's go check and make sure our sky's still clear. Oh yeah, there we go. There is our Milky Way. Looks nice. And we are up here right now. Okay. Let me just look one more time and go back. Bring up the constellations too. There's Cephas right now. That's kind of where we are. And if we get rid of this, you can see the house of Cephas right here.
Yep.
That's that. And we're kind of up in the Cephas region. Cephas.
Cepheus.
Yeah, I've heard it spoken both ways. So here's Cepheus right here. We're just right next to it.
Cepheus is the king.
That's right, King Cepheus.
He's the husband of Cassiopeia, the queen. And Cassiopeia is the mother of Andromeda.
Hmm. And Andromeda says, why did I have to have a father with the name of Syphilis? King Syphilis. Yes, I know, Cepheus. Judy M, hi. You're going to take off? All right. Thank you for coming, and we will see you a little later on another stream. Good to have you with us. Okay, what do we got now? We've actually stacked 20 of them so far. And we have Cave Nebula listed there. So I'll save it at 20 and let it go a little longer. Okay. These, what's that? Go ahead.
Oh, I was just going to say there's another dimmer red spot next to the bigger one you're pointing toward.
I mean, this right here.
No, just to the left.
Well, this one.
That one.
Yeah. That's interesting. All right, Donald. Thank you for coming. And JCO says, "We had so much fun tonight." Thank you, man. We had a great time having you. Let's zoom in on this. I want to show you. This is an interesting region because we're getting up here, we're getting this weird kind of a glow. And this glow, you'll notice it has a bluish cast. That's because this is dark dust, and it's scattering the starlight from this region and from regions around it. And so you have this little, like, over the edge, it silhouettes it because there's something going on behind it. You have subtle little feathery areas of yellow, of blue reflection nebulae, which is what these are, these blue streaks and blue patches. But they come from scattered blue light by the stars in the region. The dust is scattering the star's blue light. And now we have our nighty-night music. Well, kids, thank you for joining Sky Tour Livestream tonight. We hope you had a wonderful time. So remember, twinkle, twinkle, little star. We're not done yet. Just gonna do a few more minutes of this.
Looks kind of grainy. Is that from the gain being set so high?
Yes. I would have to go a lot more frames than just the 25 we've got now. I'd have to go to 100 frames to start minimizing that. But what I can do is take our histogram values here, and this is fine. I'll bring the music back down because I was all twinkle twinkly little starry. And now if I take this and I drag it down, you'll notice the grain is minimalized or minimized, okay? But you see slightly less detail because we've removed some of that captured data. But over time, you'll see you can make it brighter and brighter and more detailed. The cave, a mysterious location out there.
I see a sort of a dark beam coming out of the upper part of the cave there.
A dark beam? This?
Yeah, that right there.
Yeah. It looks like a dark nebula. That's cool. And if you look here, we bring this down, you can see that this continues, and then it goes here too. So this is a large set of rays. Okay, let's at least dock that back up for now. Alright. Let's see where it wants to go. If we do this, it automatically tries to do that. Yeah, that's what I thought. Not bad.
Michael H. has a question of you.
Let's see. When will solar cycle 25 hit its peak? I don't know. I gotta check, Michael. I don't know.
I saw someone the other day say it's already past its peak.
Okay.
I don't think that's the case, but Michael, it's one of those things they'll be able to say after the fact
Yeah,
when they see sunspot numbers start going down again.
yeah. That's because we know so much, Michael. Can't you tell? Even astronomers don't have all the answers sometimes about astronomy. I think these four stars are really kind of interesting. It's almost like a trapezium inside the cave, Darrell.
Mm-hmm.
Look at those four stars.
Oh.
Really pretty. Approaching 32 images. Yep. That's something else. This is such a beautiful region. I mean, the universe is beautiful to me anyway. I've always felt this, as you guys know. I'm one of those weirdos. I always had my telescope out. It was a 2.4 inch refractor. And I would look at many things in the sky. I'd look for nebulae. You could never see them. I lived in a relatively light polluted town of Plainville, Connecticut. And I'd take the telescope out winter, spring, summer, fall, and it would be cold, so cold that it touched it. The worst time I ever had was in the middle of winter. I was looking at the moon through the eyepiece, and it was the middle of winter, and I breathed out at one point. It hit the lens of the eyepiece. My eye happened to contact the lens of the eyepiece, and it froze to the eyepiece. So I just quickly loosened it out of the tube, picked it up, and ran in the house, and it hurt. It felt like I was yanking out my eye. I was terrified. I got in the house, and as it warmed up, it just came right back off, and my eye was burning for a couple days after. But it was very sensitive to blink. It felt like you had sand in your eye. It was awful. There's 35. Okay.
I set up at 10 below 0 Fahrenheit several times. A couple times when I was up in the high country and
Leadville?
Yep, once down here.
Yeah.
Oh, we had a batch of minus 35 Fahrenheit weather in Leadville.
Wow.
And then it warmed up to minus 10, so I said, heck with it, I'm taking the scope out.
You had temperatures of Barrow, Alaska.
Coldest I ever saw up there was minus 42 at my sister's place, and it was minus 48 a few miles away.
Wow. I mean, that's weather that makes corpsicles.
Yeah. Then try adding 70-mile-an-hour winds on top of that. See what the wind chill is.
Wind chill is death chill. That's death chill. I took off the enhancement here to see if the noise is better. It's going to be better, but I just want to see what it looks like. Oh, see that? Not bad, no.
Yeah.
Oh, no wonder. I had it set higher still. I'm going to take it down. I'll put it back on, and I'll drop it down a notch to 1.88. Okay, that's a little bit more livable. Wow. You see what our full width half maximum filters do? Those stars inside are still 4 little dots and not elongated. That's beautiful. We only lost 1 here, and then 2 more, yes, down there at the beginning. And naturally, a satellite comes through and ruins that. But it's only in 1 frame. taking pictures for years. Only in the last 5 have, maybe 6, have satellites become a really serious problem. Yep. No goo, that's a no goo. Alright, we'll go to 40 and then we'll call it for the cave. And for tonight. Hell yeah. This was a great night, guys. We saw a lot of nebulae. We learned a few things, I think. There we go. Okay.
I'm going to keep digging on whatever that was I was wanting to see.
It wasn't the cosmic bat?
No.
Right.
I thought it was right next to the Seahorse, but evidently not. I'll have to keep looking.
Okay. Sam S. got frostbite on his ear thanks to the military sending him to Alaska. Alright. I'm glad you're okay now.
When I worked up at the mine, it was on top of Fremont Pass here in Colorado. It was like 11,300 feet elevation. In winter, we had a blizzard hit once. It was minus 35 Fahrenheit, 70 mile an hour winds.
Wow.
And we had to go out and work outside, and we were not dressed for it.
Oh, jeez.
And you talk about awful. I'm surprised nobody got frostbite that time.
Wow. Okay, now look at this blue nebula here. It's fleshing in very nicely. We'll take out the noise and you'll be able to see that. There's some very, very fine tendrils of dark dust in here. Very nice. Let's do this. Alright. That's beautiful.
Well, thanks for having me on tonight, Mark.
Oh yeah, it's been great. Alright guys, well listen, it's been wonderful. And we will see you again on the next Sky Tour. Hope you guys will have a good night and a good time was had by all, I hope. So, I guess we'll have to say good night for now, right? Think so. Alright everybody, have a good night. We'll see you.
Good night, everybody.
Bye-bye. More to come, I can tell you that.
Sure.
Stars so bright in the sky. On Arizona nights they fly. Nebulae in colors rare. Galaxies beyond compare. Sky tour in the night so clear. Brings the universe nearer. Real-time wonders to see. Streaming light for you and me. Lift your eyes to the skies. Universe in all its light. Sky tours bringing the views. Every night feels brand new. In the dark, the night unfolds. Stories of the cosmos told. Through the lens, a distant dream. Living real like a gleam. Far away, up so high, across the stars beyond the skull. Through the lens, a distant dream, living real like a gleam. Lift your eye up so high, across the stars beyond the sky. Sky tour shows us the way, every night a new display. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views, every night feels brand new. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views, every night feels brand new.